Hello and good afternoon, CSI257 students for the fall 2014 semester at Anne Arundel Community College. This is for the Scaling Networks course, which is the third of 4 courses in the Cisco Networking Academy curriculum. Today's PacketTracer tutorial is going to be on PacketTracer activity 8.1.2.5, where we're going to be configuring manual route summarization. Alright, so let's go ahead and take a look at the activity. We've got our addressing table that shows the interfaces for the IPv4 and IPv6 components. So the objectives for this lab are going to be to configure EIGRP manual summary routes for IPv4 as well as IPv6. So EIGRP is already configured. However, we need to go ahead and configure the summary routes on the specified interfaces. So EIGRP is going to replace the current routes with a more specific summary route. Alright, so for the IPv4 piece, so display the routing table on each IPv4 enabled router and verify that the routes are visible. So we'll go ahead and we'll pull branch 1 up first. We'll put it down here. We'll make this a little larger. So I'm going to go from user exec mode into privilege exec, and to display the routing table it's going to be show IP route. And so as you can see down here, we're certainly picking up the 3 routes that are coming from branch 2, I'm sorry, the 4 routes that are coming from branch 2, and so it's clear that there is no summary of those routes. So let's pull up branch 2 and let's see what branch 2 sees. Make that a little larger. We'll take a look at the CLI here. Go from user exec to privilege exec and then a show IP route, and we should see the 4 routes that are coming from branch 1, and we do, and there they are right there. Alright, let's take a look at what the IPv4 edge router sees. So we'll pull up the IPv4 edge router and we'll go from user exec into privilege exec, and then we'll do a show IP route. Alright, and as you would suspect, the edge router, which is connected to both branch 1 and branch 2, sees all 8 of the routes, the 4 being advertised from branch 1, which are the first 4, and then the last 4 from .12 to .15 that are being advertised from branch 2. And then finally, we'll take a look at HQ IPv4. And we would expect to see the same thing here. So if I type in, or go from user exec to privilege exec, the show IP route, and as you would expect, we do. And we actually pick up 2 additional routes, the .6 and the .7, and those are also coming from the 10.10.10.2 interface on HQ IPv4. Okay, so let's take a look at our next step here. So calculate and configure a summary route on branch 1. So by looking at the routing table on IPv4 branch 1, or IPv4 edge, we are seeing all 4 networks, so we're going to calculate the summary address for branch 1 for the 4 addresses there, 4 networks. And then we're going to configure branch 1 to advertise those EIGRP summary route, or the summary route, to the IPv4 edge. And then we're going to check to see that the IPv4 edge only sees a single route. Alright, and so this is really where if you see things like this when you're taking the exam, you'll notice that oftentimes there are a whole host of very close choices, and so summary is one of those things that catches students, especially trying to go from the binary to the decimal, and from decimal to binary in your IP, and then calculating the matching bits. And so if we take a look at the branch 1, so we have a 172.31, right? Whoops, and that actually makes it look like an IPv6 address. So 172.31 dot, and then we have .8, .9, .10, and .11. So here is our dotted decimal format. Now we can clearly see that for all 4 addresses, the first 16 bits, right? There's 8 bits here in the first octet, 8 bits in the second octet, that these are going to be identical. Because if I look over here on the addresses, you can see that the 172.13 And I'm making that a little too thick. Let's drop this down to as thin as we can get it. There we go. So let's clear that away. So as you can see here, right, that those first 16 bits, the 172.31, those are identical. So the bits for all of those IPs would be the same. So if I come back over here, we take a look at what we would like to call the interesting octet. And that's going to be the third octet right here. So we've got .8, .9, .10, and .11. So what we need to do is we need to convert those from decimal into binary. And so 8 is going to be 0, 0, 0, 0, 1, 0, 0, 0. Remembering that the first, the leftmost bit is going to have a value of 128, and then 64, 32, 16, 8, 4, 2, and 1. Right? So this is the binary representation of the decimal number 8. So now we're going to do 9. So 1, 2, 3, 4, and we know 8, 0, 0, 9, right? So that's going to equal 9. And then we've got 10, 0, 0, 0, 0, 1, 0, 1, 0. And that equals 10 in decimal. And then 0, 0, 0, 0, 1, 0, 1, 1. And that equals 11, because you have 8, 9, 10, 11. Okay, so now it's rather quite simple to finish our summary. So we simply do what we would have done here on the first 16 bits. We match up the like bits, right? And we continue to move from our left to our right. So here all of the bits would have matched, so that would have been 8. All of the bits would have matched with this octet, so that would have been 16. So we have 17, 18, 19, 20, 21, 22, and then you'll notice they're no longer similar. So I'm going to change my color here. So they're no longer similar here. So it's the last 2 bits where it changes. And you can see here where we have 0, 0, then 1, 1. Whereas here, all the bits are the same. So 16, 17, 18, 19, 20, 21, 22. So we already know our CIDR notation, right? And this is also going to tell us what our net mask is. So it would be 255.255 dot, and the /22 is going to be 252.0. So we have our CIDR notation, we have our net mask, and now it's just simply a matter of making sure that these are the only addresses that are going to be represented with this summary. And the way you tell that, and let me switch colors one more time here, we'll go over to green. So the way that you tell that is you take a look at the dissimilar bits, right? And in our example here, it's these last 2 bits. And you make sure that each of the possible combinations is accounted for. So 0, 0, 0, 1, 1, 0, and 1, 1. So with these 4 combinations, we have the maximum number of combinations, and they match, right? Or I shouldn't say they match, but they're represented here. So 0, 0, 0, 1, 1, 0, and 1, 1, which means that our summary will only include these 4 routes. And this is a little, maybe a little outside the scope of the CCNA, but very important to understand that if for whatever reason, let's say we were only summarizing, the question was, give me a summary route for .8, .9, and .10, but it did not list .11, our summary could not include only these 3 routes. That we would end up with a very similar summary. We would end up with the same summary. However, the same summary would include .11. I'm sorry, I shouldn't say .11. But it would include the 172.31.11 network, right? And that may or may not be what we want. Okay, so we know we've got a /22, so we're good there. So, oops, give a check over here. We're good there. We got a check here because now we know our net mask. And so now we need to figure out what is this summary going to look like. So it would be 172.31 because those all match, and now we match here. And this is also something that catches students sometimes. Remember that it's more than just what matches. If the bit value is active or on, then this is the value in the third octet. This is the octet we're dealing with, so this would be the third octet. So the value here would be .8, and then everything else is zeros / 22, right? So on branch A, this is going to be our summary network, and so I'll say branch A. So that's our summary network for branch A. So let's step back to the activity and see what it asks of us here. So configure, I'm sorry, branch 1. I think I said branch A. Let me jump back over here real quick. So we're going to do Control-Z, branch 1. Sorry about that. Okay, so we've calculated our summary for branch 1. So let's hop onto the branch 1 router now. And remember, first take a look back over here. This is the IPv4 edge, and so what he is seeing advertised to him right now are all 4 routes coming from branch 1. So when we're done here, he should be receiving a single route from branch 1. So let's pull branch 1 up, and we're going to take a look at the interface. So do show IP interface. Oh, actually, we don't need to do show IP interface brief. Let's see what all our interfaces look like. And so here is our interface up to the IPv4 edge. And so with the summary, with EIGRP, we're going to configure that summary on the interface. So we're going to go to global config mode, into interface configuration mode, and then I'm going to say IP summary address, EIGRP, and the process is 1, followed by the summary IP address. So 172.31.8.0, and then it's going to want the net mask. And so we're going to put in here 255.255.252.0. Now I'm going to put a question mark here at the end because you can actually change the administrative distance of the summary address if you wanted to. However, here we're not being asked to do that. So I'm going to go ahead and I'm going to hit enter. And what we're going to see is a sort of a soft neighbor change here where it simply refreshes the neighbor relationship, the adjacency between branch 1 and IPv4 edge. So if I do a do show run, and what I want to see, and those are loopback interfaces that we just summarized, so this is what it looks like right here. IP summary address, EIGRP, and you can see it gave us the administrative distance of 5 by default. Okay, so we've got that command typed in. Let's jump back over to IPv4 edge, and we're going to go ahead and type show IP route. And so now you'll notice that we only see a single route that is 172.31.8.0/22 that represents all 4 of the routes that were previously advertised from branch 1. However, if you look here, you can see that branch 2 is still advertising all 4 routes. And so we're probably going to be jumping to branch 2 next here, and we certainly are. Okay, so again, we created a single summary, and so we configure that summary statement on the interface that is facing the router, the edge router, where we want to summarize, where we want that route to be summarized. And there's a lot of conversation around, why summarize? Is it easier on the CPU and the RAM? Well, today, you can certainly summarize today, but it's not so much that it's easier on the CPU or it's, with resources today. I mean, you can have hundreds of thousands of routes. I mean, you get gigs of RAM inside of your router, and the CPUs are lightning fast. So it's really not so much a problem today in your enterprise network with CPU and memory resources. It's more so to limit the query domain. And remember that EIGRP, when it loses a route and it's trying to find a feasible successor route, or it's trying to recalculate, it's going to send queries out asking, hey, do you know how to get to this route? Hey, do you know how to get to this route? And so really by summarizing, we're kind of limiting the size of the query domain. Okay, so let's jump into step 2, branch 1. We're going to do step 3. So now we're going to go ahead and take a look at the IPv4 edge, which we just did right here, right? And we can see that branch 2 is still advertising 4 routes. And so we're going to go ahead and calculate the summary address for branch 2, and then we're going to advertise that up to branch 2. So let's jump back over here. I'm going to flip the page, and we're going to go ahead and say that we've got 172.31.12.1/24 right now, but we also have .13, .14, and .15. And so we want one route, and we're going to say this is branch 2. So we want a single route that can represent these 4 routes, or these 4 networks, and only those 4 networks. So again, the 172 and the 31, those are constant throughout here. So we've got 16 bits that match already. So this is the interesting octet. We need to figure out here how many bits are going to match and what is that going to look like. So let's do 12 first. So 12 would be 0, 0, 0, 0. We need the 8, the 4, and then 0, 0, and that equals 12. So again, we're going from decimal to binary. So then 13 would be 0, 0, 0, 0, 1, 1, 0, 1, and that's 13. And then 14 is going to be 0, 0, 0, 0, 1, 1, 1, 0, and that's 14. And then 15 would be 0, 0, 0, 1, 1, 1, 1, and that's 15. So if we take a look here, and let me go ahead and change my color up, we'll go to blue. So we're all good here. These are the same. These are the same. All of these bits are the same, right? And then I'm a little off here, so it's still going to be the last 2, so we're going to have to make a little detour there. Okay. So I think you can still see clearly that this is very similar to the one that we just did. So we've got 16, 17, 18, 19, 20, 21, 22 bits match. So we know we're a /22, which means our net mask is going to be a 255, 255, 252.0. And do we have every single possible combination of the bits that don't match? Is this correct? So 00, 01, 10, and 11. So we do. So we know that these 4 networks can be simply summarized by a single network, which would look like this. And let's remember that that third octet, these 1 bits that match, right? These bit values are on. So we're going to have 172.31 dot, and this is an 8 and a 4, so it's going to be .12.0/22. All right, so let's go ahead and step over to branch 2's router. And let's take a look at what branch 2 has going on right now. So we'll go from user exec into privilege exec, and we're going to do a show IP route. So we see some routes here, and then we'll do a show IP interface brief, and we're going to check to see which serial interface, and it looks like it's 001. So I'm going to say, oops, we're going to go into global config mode and then into interface subconfiguration mode. And I'm going to say IP summary address, EIGRP, process ID is 1. And what is our summary address? 172.31.12.0 and then 252.2.0. As you can see here, it does a quick soft reconfiguration, right? Because we've changed what we're advertising. We've put out a new route. And so now let's come over to this IPv4 edge. So as you can see here, same thing with the IPv4 edge. I did a soft reconfigure, and now I'm going to say show IP route, and as we would expect, we see only 2 routes here learned via EIGRP, and they are both summary routes, and these are the interfaces on which they're being learned, right? Serial 000 and 001. And so we've compressed the number of routes in the routing table. It also makes it easier for you to read. However, you also have to be able to quickly discern okay, 172.31.8.0/22, what exactly, how many routes are in there? Which routes are being summarized? Okay, so let me take a step back to branch 1 here. So I'm going to type in. If I type show IP protocols, you can also check to see if summarization is automatically configured. And as you can see here, automatic network summarization is not in effect. And again, we're not automatically summarizing, we are manually summarizing. And that should be clear because we're doing a lot of manual work over here trying to calculate what that summary route's going to be. If I do a show run and we go down to the section EIGRP, you can also see that it says no auto summary. Okay, so let's go down to step 4. So it says, although HQ IPv4 has 2 routes that represent the 8 loopback networks, these 2 routes can be summarized into 1 route. So it wants us to take these 4 and these 4 and to summarize them down into a single route that is now going to be advertised from IPv4 Edge up to the HQ IPv4 router. Because again, from IPv4 Edge out to HQ IPv4, we don't need to send 2 routes. We can send a single summary that will represent each of these 8 routes. And so let's do that calculation and see what that looks like. So we're going to go to a fresh page here. And so we've already done the summary for the 172.31.8, 9, 10, and 11. Now we've got 12, 13, 14. So we're really looking to see from 172.31.8 all the way up to 172, whoops, let's clear that up there real quick, 172.31.15. And so we're going to go from decimal into binary. So 8 would be, again, 1, 2, 3, 4, 1, 1, 2, 3. I'm going to try to keep these lined up here for us. So then 9, again, is going to be 0, 0, 0, 1, 0, 0, 1, 10, 1, 0, 1, 0, 11, 0, 1, 1, and then we've got, whoops, we'll keep that same color, 12, we've got 13 next, and then 14, 0, 0, 0, and 12, 13, 14, and then finally we have 15, 0, 0, 0, 0, 1, 1, 1, 1. All right, so let me change colors here. We'll go back over to this reddish color. All right, so it's the same process, right? So we're trying to figure out what single summary route for these 8 networks, .8, 9, 10, 11, 12, 13, 14, and 15, what single route, and can it be a single route, can we use to summarize them? So again, we look at the bits, we see where do they match and where do they stop matching. And so here, little dotted line down here, you can see that here clearly they stop matching, right? So all of the bits match to here. This bit position is active, it's on, right? This bit value, and so we know that bit value is going to be .8. So these first 16 bits match for the first 2 octets. Then we have 17, 18, 19, 20, 21. So we know right now we've got a /21, and that's going to be a 255.255.248.0. So we've got our CIDR notation, we've got our net mask, we know what the value of the 3rd octet will now be. Everything else becomes zeros past the bit boundary where they no longer match. So our summary would be 172.31.8.0/21. And so this is the summary route we are going to advertise from IPv4 Edge to HQ IPv4. Now, before we move on, let's take a quick look here. You need to remember to check, right? And when you, it's same thing with ACLs, and ACLs are part of the 158 course. And so when you start to do access control lists and you're trying to lock things down to a certain range of addresses. It's the same thing when you're doing your summary. You need to check to see, hey, do I have every possible combination here, or is there a network that I might not be representing here, or that I may be representing here that I unknowingly representing? So again, these last 3 bits, 000, 001, 10, 11, 100, 101, 110, 111, and a very quick way to figure it out is however many bits are to the right of the last set of bits that match. So here we have 3. The number of networks is simply going to be 2, to the number of bits on this side, on the right side. So 2 to the 3 is 8. So we know we need to have 8 networks. If only 2 of the bits didn't match, 2 to the 2 equals 4. And this is what we had in our previous calculations, where we had just those 4 networks that we were trying to summarize. And so again, we have every possible combination here of these 3 bits. And so we know that this summary route is going to represent the 8 networks that we want it to, and only those 8 networks. Again, if I had told you, or if the question had asked, give me a summary route from .8 down to .13, right? That would be a problem, because as you can see, we don't have every possible combination. We would be missing these 2 networks here, .14 and .15. And so by using this as our summary, which is what this would work out to if we stopped, even if we stopped at .13. If I said, give me a summary route for .8 to .13, you're going to end up with this as your summary route. And so these 2 routes here, which you may or may not want to be included here, are going to be included, because we need to make sure that we take into account every possible combination of these last sets of bits in order to calculate, or to figure out, hey, what networks are we representing, or are we representing and unknowingly possibly, representing those networks in our summary. Okay, so we've got our summary here. So now let's go ahead and jump onto IPv4 Edge, and let's do a quick look here. So again, same thing, show IP route, and so I've got routes that I want to go ahead and summarize. So I'm going to go into show IP interface brief, and let's see which interface it is. Serial 010. So we'll go to global config mode from privilege exec into interface config mode to serial 010. And again, we're simply going to say IP summary, and it's IP summary address, EIGRP, the process ID is 1, and what is my summary? 172.31.8.0, and it's going to be 255. And actually, let me make sure that we go from user exec to privilege exec. We'll do a show IP route, and you can see here that I'm now receiving the 2 summaries, right? And I wanted to make sure we looked at this before to make sure that we can see that the change actually did what we expected it to do. So there's your 172.31.8.0. So we'll jump back over here. So 255.248.0. And so again, what we're doing is we are telling IPv4 Edge to advertise over to HQ IPv4 a single summary route, which is going to be 172.31.8.0/21 instead of the 2 routes it's currently getting, right? Just trying to make it more efficient. And so let's go ahead and jump back in here, and I'm going to hit enter. We're going to get that reconfiguration, right? And it says new adjacency is up. So I'm on the IPv4 Edge. Nothing in the IPv4 Edge routing table changes, right? Because IPv4, he's still receiving 2 summaries, and he's going to, one from branch 1 and one from branch 2. What we're trying to do is we're trying to say, I want to summarize these routes, these 2 summaries I'm getting. I'm going to summarize those to HQ IPv4. And so now let's come back here to HQ IPv4, and you can clearly see that we were getting the 2 summaries, and it was great. But now we've been able to consolidate things even further. So if I do a show IP route now, you can see that we are now only receiving a single summary route, 172.31.8.0/21, and that single summary route represents the networks .172.31.8, 9, 10, 11, 12, 13, 14, and 15. Okay? And so all of these routes are represented from IPv4, or being advertised from IPv4 Edge out to HQ IPv4. And again, it makes it a little easier to read, right? We're not looking at 8 entries or 2 entries for that matter. We're looking at a single entry that represents all of those networks. And so that is manual summarization. All right, so if we come down to part 2 is going to ask us to perform manual summarization for IPv6. And so what's interesting here is you'll notice that we're already complete. So we've got 50 out of 50, and I'm not sure if this was intended or if this is a bug, but it's clearly asking us to do the IPv6 configuration. However, there is no scoring that's available. And in fact, if I were to click on check results, and actually let me go to the pen and let's clear that out. So if I were to go to the results and take a look at what the tasks are that we need to complete, come back up here, you can see that with the status, it's actually only scoring us on the IPv4 tasks. And so even if I expand and collapse, as you can see, we're only being asked to deal with the IPv4 tasks. And so we're going to go ahead and walk through the IPv6 anyway. It's definitely something that you should know how to do, and that you want to make sure that you're clear on. So let's go ahead and let's jump right in here, and give me 1 second. I'm going to close this down, and we're going to have to slide this guy over. All right, so if you were just looking to complete the exercise, you're done. You've got 50 out of 50. However, again, part 2, we clearly need to be able to deal with the IPv6 setup, and it's actually just a little trickier than the IPv4 because of the fact that we need to do the, we're dealing with hexadecimal now, so we're going to need to do the hex to decimal to binary conversion, and we are clearly dealing with, if you look over here, the same values that we were, right, in binary anyway. So 8, 9, 10, A is 10 in hex, B 11, then you have 12, 13, 14, 15. So this should go a little faster, but we want to make sure we take a close look at the IPv6 and how we do that. So again, we've got branch 3 and branch 4. So it wants us to start with branch 3, and it wants us to configure a summary for these 4 IPv6 addresses. And so let's step over here real quick, and I'm going to go ahead and shorten the address. So we know that we've got the 2001 colon DB8 colon 1 colon, and then remember it's the 4th hextet where we're dealing with the subnet, right? And so we're clearly subnetting over here. So if the first 3 hextets all match, and they do in our case, then we've got 48 bits, right? Remembering that a hextet, that each of these guys is 16 bits, right? So let me see if this makes it any thinner. No, that is definitely not what I was looking for. Let's see there. Does that make it any thinner? No, this is going to be purple. Just trying to get a little thinner. There we go. All right. So we'll go with that. We'll flip over here to blue. All right, so each of these guys is 16 bits. Okay, so 3 of them together, if they all match, just like the IPv4 address, we've got 48 bits that match. So now we're dealing with the 4th hextet. And so 0008, 0009, 0000A, and then 000B. As you can see right over here, this is what we're dealing with right now. So you can see we've got the 4th hextet 89 A and B. Okay, so back to our calculation. So again, it's not so much the rules of zeros here, right, that we can drop the zeros, but we can drop them because they match. All of these bits in each of these hexadecimal characters match. Remembering that a single hexadecimal character is actually 4 binary characters. So 0 in hex is equal to 0000 in binary, right? And that's, again, that's why they call it a hextet, because each hex character is equivalent to 4 binary bits. So 4 times 4 is 16, right? So if these are all going to match, we know we've got 4, 4, 4. We've got 12 additional bits that match. So with the 48 bits for the first 3 hextets, along with, and we're on the nibble boundary, or I shouldn't say, yeah, I guess the nibble boundary here, so to speak. We've got this nibble, and this nibble, a nibble being 4 bits. So those all match, so that's 12 more. So right now we're already at 60 bits that match. 48 bits plus the 12 bits is 60. So what we're really dealing with here, we're dealing with this last nibble, right? The last nibble within this hextet. And so the value of 8, we're going to convert this now to binary, is going to be 0, 0, 0, 0. I'm just doing the 4. So these are the 4 places for the bits, right? So 8. And it's the same thing. The values are 1, 2, 4, and 8. So what is 8 going to look like? 8 is going to look like 1, 0, 0, 0. 9 would be 1, 0, 0, 1. A, which is equal to 10 in decimal, will be 8. Whoops. 8, it's not going to be the 4, 1, and 0. And then we have B, which is going to be 11, right? And so that is going to be 8, 0, 10, 11. Okay? And so those are each of the hexadecimal characters in binary values. And over here, these are the decimal values that I wrote down really quick so we could see A and B. So again, the process is really the same at this point. I take a look, which bit positions match. So the first one matches, the second one matches. However, you can see right here, just like the IPv4 exercise we did, this is where things no longer match, is in that third location right here. All right, so this is where it gets a little tricky. So I already know that I've got 60 bits that match. So if I'm looking here, I might say, okay, well, it's going to be 61, 62, right? And you would be correct in assuming that it's going to be 61, 62. So we're going to have a slash 62. Thank goodness we don't have to work out a net mask value, right? And again, this is in IPv6, this is referred to as the prefix length. Prefix length. They don't call it a net mask. So no net mask in IPv6, thank goodness. So we've got 62 bits that match. We've got these last 2 bits over here, just like we did before. So 2 to the 2 equals total possible combinations are going to be 4. And it's easy to see here, 0, 0, 0, 1, 1, 0, 1, 1. We've got them all, right? Every possible combination is here. And so we know that our summary route is going to match the 4 routes that we're looking to match, and only those 4 routes, and exactly those 4 routes. All right, so we're at a slash 62, and then we've got to make sure we take into consideration, again, that this value, right, this bit position value is on, and we know that that bit position value is 8. So our summary address is going to be 2001 colon db8 colon 1 colon, and that's a terrible 1. Here, hold on, let me, not having much luck on the 1, so we'll say 1 colon 8, and then we've got colon colon slash 62, and this is our summary address for IPv6. Okay, so let's go ahead and hop on to branch 3, which is the branch that we were just dealing with. And let me change the pin and clear the screen here. All right, so we'll come back over here to the CLI. And so just like we did with IPv4, we'll go from user exec into privilege exec, and then we're going to go into global config. And I'm going to jump into the interface. Let's do a do show IP interface brief. It should be 000, and it is serial 000. So interface serial 000. And now I need to be careful here, because if I typed in IP summary address, right, that would be for an IPv4 address. So IPv6 summary address, EIGRP1, and then I'm going to put in my IPv6 address with the prefix length, and here we're 2001:DB8:1:8:/62. And that is going to represent those 4 networks. And again, you'll see there are no points, but we get the new neighbor relationship. And I should have pulled this guy up first here, the IPv6 edge, and taken a look. If we do a show IP route, it's kind of after the fact, and we don't see anything. So I type show IP route. Remember, IPv6, it's got to be show IPv6 route if I want to see the IPv6 routes. And let's see, do we pick up that advertisement? So we do, and here it is right here, right? 2001:DB8:1:8:62. And so we have that summary address. All right, so we also show, as you can see here, we've got additional routes for where are we at? DB1. So here's C, D, E, and F. And if we look over here, we're going to be dealing with these guys next. So we do get to see that it does show these 4 routes. We're going to consolidate that down to a single route. So let's jump back over here and let's walk through the IPv6 summary one more time. Okay, so we're going to be dealing with 2001:DB8:1. Boy, the ones are killing me today. 1: and it's going to be Charlie, Delta, Echo, and Foxtrot, right? So these 4 networks, we want to do a single summary to represent those. So again, these 48 bits already match. We know the leading 3 zeros that have been dropped here, right, due to the rules of the zeros, that we can drop those out. That's 12 additional bits, so we've got 60 bits that match. And if I was a betting person, which I am not, I would definitely say that we're probably going to end up with a /62 again. So let's check. So C has a decimal value of 12, D is 13, E is 14, and F is 15. So it should be fairly simple. So we've got our decimal values here. These are the hex values. And so now we're going to take these and we're going to do binary. So 12 in binary is going to be 8, 12, 0, 0, and then 13 is 0, 1. 14 is going to be 1, 1, 0, and 15, 1, 1, 1, 1. Same process. Let me flip colors here. We'll pick a green. All right, so where is the bit boundary? Where are they no longer similar? And it is right there. So 2 additional bits match. So we already know we're going to be a /62. And this is our prefix length, not the net mask, prefix length in IPv6. Okay, now a little different, right? So from the last one that we did with the 8, where only this bit position was active, both bit positions are on. So the value is 8 and 4. Now here's a common mistake that students will make, because we're very familiar with IPv4 summarization. So when I see IPv6, if I were to make the mistake and say, oh, it's 8 and 4, it's 12. So my address would be 2001:1:12. And that would be wrong. And if I were to say ::/62. So let me definitely change the colors here. So that is wrong, right? because once we figure out the value of the bit positions that match here, when we're trying to figure out our prefix length, right, in the subnet area, I need to convert the binary back to hexadecimal. So we go, step 1 is to go from hex to decimal. Step 2 is to go decimal to binary. And then step 3 is to go from binary back to decimal. Step 3. And then step 4 is to go from decimal to hex. Right? So there's definitely some additional steps in here as opposed to the IPv4 work that we've been doing. So now let's go ahead and take a look at this again. So if it's 8 and 4, we know that it equals, well, I should be up here. We know that that's going to equal 12, but is 12 hex? It's not. So what is the hex value for the decimal representation? 12, and we know that that is going to be C as in Charlie. So our subnet would be, we'll say X on this one, we'll do a check mark here. It's going to be 2001 colon DB8 colon 1, get that right, colon, and it's not 12, it's Charlie colon slash 62, right? So that is your summary address. And again, the mistake students will make coming off of IPv4 subnetting is, oh, okay, so I've got 8, I've got 4, I've got 12. You might be in a rush, and so you throw the 12 in here, and that is wrong, right? We've got to convert that back to hex to work it into that IPv6 address. And so let's jump over to branch 4 here, and let's make this happen. Let's go ahead and put our summary in here. Let me stretch this out. Go to the CLI, so 001 is the interface we're interested in. So we're going to go from user exec to privilege exec. Let's do a show IP route, and that reminds me, over here I want to do the show, the show IPv6 route, and as you can see, we're still seeing Charlie, Delta, Echo, and Foxtrot. Now those 4 should go away. We should only see one route. It should be a /62 summary. Let's see if that happens. So I'm going to jump back over here to branch 4. Show IPv6 route, I apologize. So there we go. Okay, so we're going to go into global config mode into interface serial 001, and I'm going to say IPv6 summary, and it's going to be EIGRP1, and my summary address is going to be 2001 colon DB8 colon, where did we leave off there? 1 colon Charlie colon slash 62. And so that's my summary address. We get our soft reconfiguration. Let's come back to branch 4, the IPv6 edge here. I'm sorry, not branch 4, but IPv6 edge. And let's see if the change on the branch 4 router, show IPv6 route, let's see if that had any effect. And it certainly did. So here is the specific route. I was going to highlight both. So here is our specific summary route right here. And now as you can see, we have 2 summary routes, one from branch 3 and one from branch 4. And so these 2 summaries represent 4 networks each for a total of 8 networks. And so we're going to have the same follow on here. It's going to ask us, it says, hey, take a look at the IPv6 edge and see, we've got these 2 summary routes here now. Can I collapse these down into a single summary? And we should have a pretty good feeling that we're going to be able to do that just based off of the fact that the values over here are the same as the values here, right, in the subnet hextet. So let's take a look at IPv6 edge, and we want to do a show IP interface brief, and let's see which interface, show IPv6 interface brief. And let's see here, it's going to be this guy right here. So serial 010, the same as it was with the IPv4. Same interface, that is. All right, so that's the interface on which we're going to make the change. Let's take a look at the HQ IPv6. And let's see what our headquarters sees. So we've got, go from user exec into privilege exec, show IPv6 route. And right now I am just seeing these 2 summaries. right, that we've already created. So now we want to collapse that down. We want to condense that into a single summary. So let's jump back over here. Let's go to a fresh page and let's get to work. All right, so we've got 2001 colon DB8 colon 1 colon, and we're going to have colon 8 through, and I almost did colon 15, but that's not what it's going to be. It's going to be colon F, right? Remember, we're dealing IPv6 is hex. Okay, so these are the networks, and there's going to be 8 networks in here. 8 subnets. And we need to figure out, can we represent all of them together in a single summary advertisement? So we'll remember from the previous page, the leading 3 zeros, right, have been dropped from the hextet because we can do that, the rule of zeros. So we've got 48 and then 12 bits, so we've already got 60 bits, right, that are going to match no matter what. Now we're dealing with this nibble, right, that fourth nibble here we're going to deal with. And so 8 is 1 0 0 0, 9 is 1 0 0 1, 10 is 1 0 1 0, 11 1 0 1 1. And so I'm saying the decimal, right? So this is 8, this is 9, so this would be 10 in decimal but A in hex. This would be 11 in decimal, B in hex, right? So we've got 12 is next, so 1 1 0 0, so that's 12 in decimal, C in hex. We've got 13, 0 1 is 13, and that's going to be D. And then we've got 14 in decimal is echo, or E in hex, and then 15 is all ones, and that, as we know, is F. So let's switch colors up here. Let's go to the green. All right, now we take a look here. Where does our bit boundary no longer match, right? So here in this position, right, in the position with the value of 8, we match. However, that's it. And that is where they no longer match. So I've got 3 bits that don't match. So how many total networks are going to be represented in my summary address? It's going to be 8. So do I have every possible combinations of zeros here? And I've got 1, 2, 3, 4, 5, 6, 7, 8, and I do. Right? So we know our summary is going to be valid. We know it's going to match these 8 networks and only these 8 networks. Okay, so this last bit boundary, the decimal value is 8, and that happens to be the same as the hex value, 8. So we kind of got lucky there. We didn't have to maybe say, oh, it was 14, and so then now I got to convert that back to hex and say that, okay, that's going to be E. So my summary is going to be 2001 colon DB8 colon 1 colon 8, right? Because the decimal value of 8 is equivalent to 8 in hex. And then it's going to be colon, colon, and you'll notice we only had 1 additional bit here where all of the bit positions matched. So it's a /61 is our prefix length. Remember, it's prefix length, not subnet mask, LENGTH, right? So we've got colon, colon, /61, and that is going to represent all 8 networks and only those 8 networks. And so let's jump over here and let's make that change on. Remember, we're making the change where we want to make that advertisement, where we want to say, hey, I see these 2 routes and I'm going to summarize these routes to you as a single route. All right, so I'm on the IPv6 edge. I think we said it is, what did we say? Show IP interface brief. I'm sorry. It should be IPv6. I think it's serial 001, so show IPv6 interface brief, and it is. Okay, so we're going to go into global config mode and then into interface subconfiguration mode for serial 010, and I'm going to say IPv6 summary address for EIGRP process ID 1, and we are going to go ahead and make our summary address 2001 colon DB8 colon 1 colon 8 colon /61. All right, you can see we've got that quick soft reconfiguration, and I'm going to hit HQ IPv6, and now again, whereas before, remember we last saw it right here, there are my two summaries, my /62s. Was I able to condense those down, show IPv6 route? So I'm looking for a single /61, and there it is right there. All right, so again, we were only scored on the IPv4, but very beneficial to walk through this, and hopefully you were able to stay with me here. I know this has been, we're almost an hour in here, but definitely beneficial to have an intimate understanding of IPv6 manual summarization as well. And the key is to remember, excuse me, the key to remember is if you end up in a situation where you have multiple bit positions that for whatever reason they end up matching, that when you do that binary conversion to decimal, it does not go into the IPv6 address. You have to take that extra step. You got to go this way, and you say, hey, this is 12 in decimal, but what is that in hex? Because I'm putting it back into the IPv6 address where these are hexadecimal values here. And I know that transition, especially if you're not familiar with IPv6, this transition can be difficult sometimes, especially dealing with topics that at the CCNA level are definitely complex when we talk about route summarization. Okay, so that wraps up our video for PacketTracer tutorial 8.1.2.5. I hope that you found the video tutorial informational and helpful, and hopefully it allowed you to work your way through this PacketTracer activity. All right, have a great day.